So, hi, this is the second lecture of week 9, and this is something that we probably should have covered quite early, but especially if you're using these platforms where some kind of competitive coding problems are put, they're a kind of a prerequisite is to be able to take input and send output through files, right? So this is something that we have not yet discussed. So this lecture as well as the next lecture is about file handling in C. So before we actually go to file handling, there is a basic concept that you should understand, that there are two types of files that you usually interact with on day-to-day basis. These are text files and binary files. Okay. So text files are these files that you edit in simple text editors like Notepad or Vim or VS Code, right? I mean, the reason I have used the term simple is because editors like Word, for example, the files that they produce, even though you might feel that it's a text file, it's not really a text file, right? I mean, uh, they are as we'll see, they are actually binary files. The convention is that a general purpose text file is named with the extension .txt, right? So usually if you see a .txt file, these are the kind of files that we actually call as text files. um, all other files which are not text files are actually binary files, right? So um, Word, files that are created in Microsoft Word, images, music, videos, all these are essentially binary files. The actual difference between these two is just the representation of data within the file. So text files actually store data character by character. Okay, and what they usually do is they store the ASCII representation of that particular character, right? So now ASCII is usually the default on most systems. There can be some other encoding, by the way. This is the whole aspect of representing a character by one or more bytes is essentially encoding. And you can have other encodings as well. You might have heard terms like UTF-8 or UTF-16. So these are some alternatives to ASCII. But the idea is that whatever data you are supposed to store in a text file, it is stored in a character by character fashion. On the other hand, the binary files are just basically a sequence of bytes, right? Uh, Remember, text files are also sequence of bytes, but each byte usually represent one character, right? But when it comes to binary files, this whole representation of what each byte represents, that is application specific, right? So whatever application you are using in order to create the binary file, probably it is the same application or same class of applications that can actually read that binary file, right? So this is why one binary file that is created by, let us say, a class of applications is usually incompatible with other applications. So you're not really expected to open, let us say, uh, an image file in a video editor. Actually, you can probably in video editor, but not the other way around. You'll probably won't be able to edit a video in an image editing application, and they are both binary files, by the way, right? So this is the idea that binary files are just a sequence of bytes, and how you interpret them, that is application specific. So a very simple differentiating example is, let us say you create a file, a text file with just the number 0, okay, written in it, right? Now, as I said, because in text files everything is a character, we are now talking about 0 the character, not 0 the number, right? So even though I've written number, what I really mean is that when it gets stored in that file, it gets stored as a character, and that is why it just occupies 1 byte of space. And what exactly is that byte? Basically, that byte is binary representation of the number 48, right? Why? Because 48 is the ASCII code of 0. So if you actually open up this file in some kind of binary or hexadecimal editor, you'll see that this is what it looks like. 30 in hexadecimal actually means 48 in decimal, and there is a line feed character. Basically, in some ways it is equivalent to the slash n thing that we have seen. So So basically, there are two characters in this text file. One is the zero as the character, not as the number, and then there is a line feed. So there are just 2 bytes in this text file. But if you actually store 0 in a binary file, right, so you basically store it as an integer, right. Now integer usually occupy 2 or 4 bytes. In modern day systems, they usually occupy 4 bytes. So what in there, what is actually stored in that particular file are 16 or 32 bits, and they essentially constitute the binary representation of 0. So this is the example of a binary file that is storing 0 as a number. So you understand that this is the whatever is stored here is 0 the integer, not 0 the character, right. And this is something that you will study in computer organization, that how do we represent integers in binary. We have had a brief overview of this. Remember all that signed magnitude forms and 2's complement form. So here basically 0 is represented by all zeros. So essentially, this here means that I have 32 zeros in one sequence, right, and these are 4 bytes. So this is how a text file is different from a binary file. A binary file stores data in the form of sequence of bytes. The text file also, of course, stores stuff in a sequence of byte, but basically each byte uh, usually corresponds to a character, provided that you are using ASCII as the encoding. Now, if you want to access these files through some program, and when I say program, it need not just be a C program. The concepts also apply to other languages as well, right? So C, C++, Java, Python. Usually, all these languages they actually treat character files and binary files differently. So whenever you actually want to access a file through some program, the first thing you need to know about is that whether the file is a text file or a binary file. Then you need to decide exactly what you want to do with the file, whether you just want to read it. Then there are different set of functions, because you understand, right, that if you are just reading it, you are not changing any content of the file, and there can be multiple reads that can be allowed over the same file. Or you might actually want to write something to it, in which case you need to get some kind of an exclusive access, because when you're writing something, others should not write the same file. Others as in some other process, some other program should not be allowed to write the same file, and even the reads on that file should be disabled. So that is why, right, that there is a distinction between just reading a file and writing to the file. Okay. In most programming language, you will have some kind of library support for these types of tasks. There are 4 types of tasks now. We have 2 types of files, binary and text, and we have 2 types of operations, reading and writing. So you'll have functions for reading from text files and writing to text files, and you'll probably have functions for reading from binary files and writing to binary files. Remember, these functions, the one that do binary input output, they can always be used to do this, right. I mean, they kind of supersede the text functions, the text file functions. It's just that it's much more convenient if you have a different set of functions that deal specifically with text files. But text files, as I have already said, they too are just a sequence of bytes. It's just that you need to interpret them in a different fashion. So based on your needs, you must pick the correct set of library resources for your task. So this is general stuff. This is not simply applicable to C. This is a general programming thing. Whenever you are trying to read or write a file, these are the kind of functions that will probably be available in your language's library. So you must find out the right set of functions to use. Now, when we come to interacting with files in C, the starting point is creating an instance of a type called file. So this is basically a structure with some type definition. The final thing that you use is this file, everything in capital, FILE, right? This is the whole thing has to be in capital, and it is an alias for a structure. This structure contains a lot of information about the file. Some of the things that it actually keeps it actually maintains a kind of buffer as in a place where you can actually read stuff from the file, or you can say this is the stuff that I need to be written to the file, stuff like that. So we don't really need to know what is the, what are the implementation details of file, just that an instance of this structure, it can actually maintain whatever is required, whatever resources are required in order to interact with the file, that is maintained by the instance of this particular structure. So when you actually want to open a file for reading or writing, there is a library function called fopen. Okay, fopen stands for file open, and this is a typical scenario of how you use it. You use a pointer to this file, right? So file asterisk something, and then you do fopen, and then you provide the name of the file, and there are some access modes. Okay, so access modes are again string. It's a string input, but you there are, the inputs that you can give here are restricted. Exactly what do you want? um, this access mode string essentially talks about what kind of operations are you going to perform over this file. So for example, if you want to just read or write some text file, the access mode string that you should give is something like this: R or W, right? Read or write. And if you are planning to open or write, open and read or write binary files, you should also add this B here, right? So essentially, by R it means, by default they are text files, and RB means that you are saying that this file is a binary file. WB again means that you are going to write to a binary file. There are actually many other possible access modes. We are not going to discuss all of them in this lecture. They are, you can actually go through them by opening up the man page of fopen. You can check your homework also. There is something related to that. This file pointer, right, the pointer to that structure, can then be passed to almost all the file related functions that are there in C to perform various tasks, right? And towards the end of the program, when all of your stuff has been completed, it's a good practice to call a function called fclose. So this fclose function is used to free up any resources, right? So let's not go into details of what these resources are. These are stuff related to the operating system, but just assume that there is some memory and some other things. There are some handles to the file that need to be closed properly. So you simply call the fclose function and pass this file. This is very similar to calling the free function and giving the pointer to the allocated memory from malloc. This is very similar to that. So now, the first use case is where you're trying to write some characters to a text file. Remember, right, that text files actually store data character by character. So two common functions that are used for this purpose are fprintf and fputs. So you can see that there is an f here in front of printf. This is not printf but fprintf. And similarly, if you might have used puts or you may not have, but here I have an f as a prefix to puts. So these are two different functions, fprintf and fputs, and both functions expect that file pointer as input, right? Whatever file pointer you created with the help of the fopen function, that must be passed to these functions. Okay, fprintf and fputs. If you write a string, what really happens is that they write uh, each character of the string in the file, right, in that particular order. So if I write hello, the first character that gets written is H, the next character is E, then L, and then O, right? So this is how these functions work. This is a very simple example of writing a simple string in a in a file. So you start again by this, right, that fopen call. As you can see that the access mode here is W stands for write, and by default it is fopen assumes that you are going to write to a text file, and then this is returned and then accepted in this variable called fptr. And then you use fprintf something like this. You pass fptr, then the this part is actually pretty similar to printf, right? Uh, from here onwards, whatever you see, it is exactly printf, right? The only difference here is that you are passing a file pointer here. So whatever is the behavior of printf, the same behavior is there for fprintf. The only difference is that instead of putting the output on your screen, the output goes to a file, and that file is pointed to by fptr. Then once you are done with all this, you simply call fclose and you give the fptr pointer to that function. And this is how it will look like when you run the program. This is a simple message. This is the string that I am supposed to send to a file, let us say, called message.txt. And if you can also open this message.txt in any text editor like vim, or you can even do a cat message.txt, and you should see this message being added to that file. Now similarly, you can also read characters from a text file. The starting point again is to obtain that file pointer with the proper access. Two common functions which are used for reading text from a text file are fscanf. Again, it is the file counterpart of scanf, and fgettys. It is again the, I think you guys might have used fgettys already. With the file pointer, at the place of file pointer you might have given std in. So now you can understand what happens, that it is essentially a function for taking inputs from files, but std in is basically another file pointer that points to your standard input. So the obtained file pointer is anyhow going to be required either for fscanf or fgettys. And this is another example where I'm just going to read the message that I wrote using that writing example. Again, the starting point is the same. You use fopen. Instead of w, you give r means read, and as I said, by default it will expect that you are going to read a text file. And then this is the idea. You essentially use fgettys. You may have already used it by the way. Instead of putting std in, we are now giving that file pointer. So what this is going to do is it will actually read up to 100 characters from the text file into the str character array. So this is a character array that I have created, and it will read up to 100 characters, unless the situation where it might stop before that is similar to how scanf stops when you do a /n. Of course, scanf also has a problem that it will stop as soon as it encounters a space, and this is why we were using fgettys. That fgettys actually delimits the input when it encounters a /n character. So basically this will read either 100 characters or up to the extent where it finds a /n character. So if you run this on the same file message.txt, this is basically what it shows. It has simply read the message that was written to it by the message saver program. Now, a little bit more about the binary files before we go through. So binary files are actually very different from text files. You need to have some kind of a predefined format before you read or write them. This is something that you have to understand. And this format involves a kind of precise description of exactly what each byte in your binary file means, right? How is it to be interpreted? So let us say you need to write three pieces of data: an integer, a double, and a character, to a binary file in that particular order. What happens is the file will actually have, say, 13 bytes in it, right? And it looks something like this. The first 4 bytes constitute the integer, the next 8 bytes constitute the double, and the last byte constitutes the character. Now the problem here is that the file, if you just open up the file in any editor, first of all you'll not see anything that can make sense to you if you try to open this file as a text file. So you will see some weird characters if you open this file in vim or vs code or something like that, or notepad. But there are certain editors where you can actually check what each byte means. There are some hexadecimal editors, but even if you open them, there is usually no way to figure out that these 4 bytes constitute an integer, the next 8 bytes constitute a double, and this one constitutes a char, so on and so forth. So what you will actually have a look at is that there are just 13 bytes written in the file, one after the other, and that can actually be interpreted in multiple ways, right? So for example, you can also say that the first byte is a character, the next 8 bytes are double, and the last 4 bytes are integer. So in order to actually interpret this data properly, you need to know this format, that when the file was written, this was the format, and this is the thing that you need to understand about binary files. These formats are application specific or even program specific, so you can choose your own format. You can write your data in whatever format you want. It's just that when you read it back, you should interpret these bytes in a similar fashion. So let's write some bytes to a binary file. Again, the starting point is exactly the same. You use fopen and um, you create a file pointer. Now by default, fopen actually opens up the files for reading in text mode or writing in text mode. So you need to suffix that b. We saw that, right? Instead of w, you have to do wb in order to open it in the binary mode. And then once you have done it, once you have that file pointer, you can use a function called fwrite. Okay, now fwrite function, it requires certain number of parameters. First, it requires the file pointer. That is, as I said, right, this is pretty much uh, omnipresent whenever you are doing file handling. You need to give the size of the data type that you wish to write. So for instance, as I told you, that if you are writing an integer, the size will be 4. If you are writing a double, the size will be 8, so on and so forth. So each data type in C, and this is where the size of operator will again be helpful. So the idea is that you tell it the number of bytes that you want to write, and then the number of elements of this type that you want to write. Now this elements thing actually makes sense when you are writing some array. Okay, let us say I am writing an array of 5 integers. So then I'll say that I have to write 4 byte data, and I have to do it 5 times. So essentially I need to write some 20 bytes of data. uh, the last another the most important parameter that you are going to provide is the actual data, right? So it could be a variable, or it could be an array, right? So an array means this makes sense when you are going to write more than one element, right? So then you can also pass an array. So this is how it looks like. Again, the starting point is pretty similar. It's just that instead of just w, I give wp, something like this. Okay, this means that this is a binary file. And now, if you remember, we said that we'll have to come up with a format, right? The format to store the data within the binary file. So here the convention, the format that I have adopted is that we are storing a list of integers. So the first set of bytes that are stored in the binary file are they represent the number of elements in my integer list. So let us say if I am creating a list of 5 numbers, the first number that is stored in my binary file is essentially 5. So the first 4 bytes represent 5. If the number of elements in my list are, let us say, 10, then the first 4 bytes of my binary file represent 10. So this is the idea. The first output that I do to the binary file is the number of elements in my list, and then I simply write an array, right? So this array, for example, is of size number of elements. So again, I used malloc to allocate it. So I have a dynamically allocated array. So now in the next stage, you can see that in the first case I simply set the number of elements, the number of variables was 1, but now I can actually write a complete array by just one call to fwrite, by giving it the name of the array and then the number of elements. So this is basically how we write, let us say, 20 bytes of data simultaneously, where they essentially are coming from a 5 element integer array, so something like this. Okay, so this is in essence the format that we are using for this binary file. An integer, which is essentially the number of integers in the list, and then the list itself, right? If the list has n elements, I am going to have n plus 1 integers written in my file, with the first integer being the size itself, that is n itself. Now this is how this program will look like when you run it. You just pass the number of elements in the list, then you give me all the numbers in the list, and then, so in this case my list is of size 5, so I'm going to use 5 plus 1, that is 6 into 4, that is 24 bytes of data is going to be written to my file. Oh yeah, and one more thing, that again, by convention, the extension we use to represent binary data is .bin or .dat, similar to .txt for text files. Now, if you want to read the same data written through the previous program, well, we start from the same place, fopen, and you also suffix b with r in order to open it in the binary mode. The rest of the process is fairly similar. Instead of the function fwrite, you use the fread function. The parameters are also similar. You basically say you basically pass the file pointer, the size of the data type that you wish to read, the number of elements. Again, this is relevant when you are reading the whole array, right? Like in this case we will require that, otherwise it will always be just one. And then a pointer to a variable or array. By the way, in the previous case also, it was the pointer, I probably should have written it, but here the pointers make more sense, because whatever address that you pass to this particular function, your data will be written, there. So fread is going to read that data from the file and write it at that address. So you remember, right, in the call by reference examples, I told you that sometimes we use parameters as a way to collect the returned value. So in some ways this is exactly what is happening, that fread, whatever it reads, it stores it at the address of one of the parameters that was passed to it, and that is the parameter for the for the variable or array where the data is supposed to be stored. So this is what it looks like. Again, the starting point is very similar. Instead of r, I am using rb, and then this is again, this is according to the expected format, right? It must match, the reading part must match with the format that I used for writing. So in the first read that I do is basically that of an integer, and that integer is the number of elements in my written list. And then I by the way, I could have simply read all of it in one go in the array, but here I have not created an array. Because I don't really need to store that that value anywhere, so what I'm simply doing is I'm running a loop, and every time I'm just reading one more integer and simply printing it. I'm not keeping these integers anywhere, so that is why I have not used an array. But you could have written something like fread ampersand arr size of int, and then number of elements, and then fptr. That too would have basically read all of the input that we wrote in that file in just one go. Here I am just reading it integer by integer and then printing it on the screen. So there is some homework. I should have also put a slide for output. So this will basically print everything that was written by the other program. So now there is some homework. Please go through this homework. So at least read about what is the appending mode, because it's a very common mode that you might use. And then please do open the man page of fopen. I have not covered all the things because I feel they are they are pretty straightforward, but please have a look at the homework. And this we are going to discuss in the class on Tuesday. Thank you. Bye.